Welcome to Unit 3, Ratios and Proportions. To begin this unit, we introduced the idea of comparing the cost it would take to go on a field trip to the number of students that were going on the field trip. So we looked at how much it would cost for 20 students, for 5 students, for 1 student, and as a bonus, I asked students to try to figure out how many students went if there were $300. So to develop this understanding even deeper of what ratios are, let's start by looking at the definition. So a ratio is simply a comparison of two or more values. Now, values can be represented numerically, so that's why we will be using some numbers. But what's also important with values is that we have names to those numbers. If it's just numbers, it doesn't really tell us much of the story. But as soon as we can put names to it, now we can really understand what's happening. So you'll get a couple examples of that in just a bit. Now, there are 2 different types of ratios that we're going to be looking at. One of them is known as a part-to-part ratio. The other is known as a part-to-whole ratio. So for a part-to-part ratio, we're going to be comparing 2 different parts within the population. So as an example, let's look at the population of these shapes. So if I wanted to compare, I don't know, let's say triangles to circles. So let's figure out how many triangles there are. 1, 2, 3, 4, 5, and there's one hidden behind there, 6 triangles. 2, how many circles? 1, 2, 3. Now, the way I have this ratio set up right now, 6:3, really doesn't tell me much. But as soon as I plug in some variables, I'm going to put a T for triangles and a C for circles. This tells me I have a ratio of 6 triangles to 3 circles. We can also write this as a fraction, 6 triangles to 3 circles. This is going to be the most common way that we're going to be writing ratios. Again, without the letters, this is just a fraction. But now, with the T and the C representing triangles and circles, we now have a part-to-part ratio. The other one we're going to look at is a part-to-whole ratio. This is comparing a part of the population to the entire population. So let's look at what part are squares. And since we're looking at a bunch of shapes, the whole population are going to be the number of shapes. So how many squares? 1, 2, 3, 4 squares. I'm going to put an SQ to label that. And now, how many shapes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 shapes. So there's our ratio, 4 squares to 13 shapes. One more time, just for good practice, the most common way we're going to see this is 4 squares over 13 shapes. Now, one of the reasons that we write these very commonly as fractions is because once we set up our ratios like this, we now have lots of opportunities to manipulate them. So our next definition is the most important unit rate, or most important ratio. It's called a unit rate. So what a unit rate is, this is a ratio I can't spell this morning. A ratio with a denominator of, I would put this in all caps, 1. So it's any ratio with a denominator of 1. As an example, something you might hear very often is 45 mph. What does mph stand for? Well, if you've ever looked in a car, that would be 45 miles per 1 hour. That is a unit rate. Now, what's important for you, in order to find the unit rate, I'd put some highlights in these stars, highlight this box. To find unit rate, we need to divide. If we go back to our shape story, take a look at this. 6 triangles to 3 circles. Well, doesn't that mean that there are 2 triangles for every 1 circle? That is a unit rate. So now that we have our definitions, let's take a look at a couple examples to see what this is going to look like at a 7th grade level. So our first example says, Doug entered a canoe race. He paddled 5 miles in 2/3 of an hour. What is his average speed in miles per hour? All right, so 3 read. We got Doug in a canoe, probably on a lake somewhere. So what is important? He paddled 5 miles in 2/3 of an hour. And what is the question? What is his average speed in miles per hour? Now, every time we set up a ratio, I'm going to expect you guys to set it up first. So what I mean by that, we're looking for miles per hour. So set up a ratio, miles on top, that fraction bar means per, and hours goes at the bottom. So now that our ratio is set up, let's go back and plug in the numbers where they belong. This says 5 miles, so I'm going to put that right here. This says 2/3 of an hour, so I'm going to put that right there. So now that my ratio is all set up, the way that this looks might not seem very helpful to you right now. So I got an idea. Let's change this division problem to 5 divided by 2/3. So now that I have it set up this way, let's go back to what we practiced in those last couple units, a little keep, change, flip. So we got 5 over 1 times 3 over 2. Multiplying straight across gets me 15 halves. Now, to answer the question, I've never heard somebody say Doug was canoeing 15 halves miles per hour. That just sounds weird. So let's go ahead and convert this back to a mixed number. So 2 goes into 15 7 times, 1 left over, and my denominator is 2. So we get an answer of 7.5, but 7.5 what? Well, let's go back to our ratio. There it is, miles per hour. So 7.5 mph. Box it up, and we're done. So just to make sure we're confident with this, let's go through one more example. Try to stay a step ahead of me if you can. So 3 read. Looks like we got a garden hose here that is spilled. Okay, so we got a leaky garden hose. So what's important? It spilled 7/8 gallons every 2/3 minutes. And just like last time, what is the question? Find the average number of gallons spilled per minute. So I'm looking for gallons per minute. Now that my ratio is all set up, let's plug them in. 7/8 gallons, that should go on top. 2/3 minutes, minutes is at the bottom, so I'm gonna write 2/3 there. Now that I'm set up correctly, let's go ahead and change this to 7/8 divided by 2/3. So we can do a little keep, change, flip. That'll get me 7/8 times 3 halves. Going across, 7 times 3, 21. 8 times 2 gets me 16. And just so we can talk about this in our language, let's change it back to a mix. 16 goes into 21, 1 time, 5 left over, and my denominator is 16. So what does this answer mean in this story? 1 and 5/16. Here it is, gallons per minute. So we got gallons per minute. You can write it with a slash, like a fraction bar, and we are done. So here's the idea of ratios and specifically unit rate. So go ahead and flip the page, try out those Explore problems. Make sure you check in with Mr. Yakubowski and the answer key. If you have any questions, just let me know.